Hello students. So in the previous class we were talking about that of valence electron and valency. In valency student we discussed that it totally depends upon that of the valence electron. If an outermost shell is having valence electron from 1 to 4, we can see that the valency of a particular element will be also 1 to 4. And if the valency of an atom is more than that of the 4, then what we will do? Then we will find if the valence electron of an atom is more than that of the 4, then we will find the valency by subtracting the number of valence electron from 8. Why we used to do that, students? So see here. Basically, we have to find the valency, and valency totally depend upon the valence electron. Okay, now the valence electron, the outermost shell, if it is having the octet, if it is having completed its octet, then we can say that that particular atom is having a stable electronic configuration. Stable electronic configuration, it means stable electronic configuration. So, a stable electronic configuration, it means the outermost shell must have a 8 electron. Valence shell must have completed its octet. So, we can say, student, that an atom, it is having the 8 electron in its valence shell. It means it possesses the stable electronic configuration. Okay, the stability decided by that of whether it has completed its octet or duplet. Okay, so not only octet, stability by completing the octet or duplet. Duplet basically in the case of hydrogen and helium. Why is it so? Because only in the hydrogen and that of the helium, number of electron present only in that of the K shell, and we know that the K shell can accommodate maximum 2 electron in its shell. Okay, and that is why we can say that the stability can be defined of an atom, that whether if it has completed its octet or duplet. If the outermost shell has completed, is fulfilled, is completed its electronic configuration, its octet, and that of the duplet, we can say that they will show the least reactivity, they will show the less bonding with the other atom, or they will be more stable. On that basis, student, we have decided the valency, and we have seen the valency of a different atomic number, that is from 1 to 10. Okay, and we have seen that how valency varies as we move from atomic number 1 to 10. So when we move from the 1 to 10, student, we have seen that first the atomic number increases. It will be like 1, 2, 3, 4 up to 4, and after that valency starts decreasing. So here it will become 3, 2, 1, 0. Okay, so at first the valency increases and finally the valency decreases. Why is it so? Because we know that valence electron up to 4 will decide the valency will be 4. Okay, but as it is more than 4, we start subtracting it by 8, and that is why you can understand that the valency starts decreasing. Okay, so valence electron determine the valency. Valency is at first it increases up to 4 because a valence electron of an atom up to 4 will decide the valency, that is 4. But if it is more than 4, the valence electron is more than 4, so we will find the valency by subtracting the number of valence electron by 8. Then you can see the valency starts decreasing and comes to 0. Now on that basis, students, there is a question given and we have to find the valency of the given atoms. You see here, students, question is that how will you find the valency of chlorine, magnesium and sulfur? Okay, So how do you find it, students? So you see here, if we are knowing the atomic number, we can find the electronic configuration. By the help of the electronic configuration, we can find the valence electron, and with the help of a valence electron, we can find the valency. So this is a step, you can say, by which the valency can be found. But if you are this much okay that you are knowing the valence electron, then it will be very easy to find the valence. So you see here, student, the first one is that of the chlorine. And we know that the atomic number of chlorine is 17. Okay. So what will be the electronic configuration of the chlorine? So it will be K, N. Right? So you see here, how many electrons will be present in that of the K shell? K shell can accommodate only 2 electrons. So here it will be 2. How many electrons will be present in that of the L shell? So it will be 8, because maximum it can accommodate 8. Now 8 plus 2 is 10. 17 minus 10, which will give 7. So 7 electron will enter into that of the M shell. So here it will be 7. Okay. Now you see here. Now you see valence electron. Is equals to 7. Why 7, student? Because you know the last outermost shell in which the electrons enter. So you see here, student, here the last shell in which the electron enter is the M shell. So we can say that M shell is what? It is the valence shell. So it is the valence shell. This is the last shell in which the electrons enter. Now, then the electrons which enter in that of the valence shell, in the outermost shell, that is known as valence electron. So here it will be the valence electron. Right? So you see here, student, valence electron is 7 here. Okay? Valence shell, valence electron is 7. Now, the valence electron is more than that of the 4. So we will apply the formula, and that is valency is equals to 8 minus number of valence electron. So you see here, student, 8 minus number of valence electron is 7. So 8 minus 7, that will be equals to 1. So what will be the valency here? Valency will be 1. Okay, so this is the method by which you can find the valency of a particular atom. So this one is for the chlorine, whose atomic number is 17. Now we will find of that of magnesium. So you see the student, for magnesium, in case of magnesium, the atomic number of magnesium is 12. Right? Atomic number is 12. So what will be the electronic configuration? It will be K, L, N. So how many electrons will be present in that of the K shell? And that is 2. How many electrons will be present in that of the L shell? That is 8. And rest of the electron, that is 2 more electrons is left, that will enter into that of the N shell. Now the last 2 electrons enter into a shell, and that shell is the outermost shell. So here, which one is the outermost shell, student? N. N is that of the outermost shell. So we will say that it is the outermost shell or valence shell. So we will write here, this one is the valence shell. So if this one is a valence shell, so here it will be the valence electron. Okay, valence shell or valence electron. Now you see here, student, this is the 2. So valence electron is equals to 2. And if the valence electron is 2, what will be the valency? So you know that if valence electron is up to 4, 1 to 4, valency will also be 1 to 4. So here also valence electron is less than 4. So we can say valency will all equals to that of the valence electron. So you will write it, valency is equals to valence electron, in bracket you can write it, since it is less than 4. Okay, so it will be equals to 2. So valency will be 2 of that of the magnesium. Now we can see that of the sulfur, students. So in case of a sulfur is equals to 16. Okay, so we can rub it and write it. In case of a sulfur, this is 12, this one is 17, and now we will see of that of the sulfur. So sulfur atomic number is 16, right? If it is atomic number is 16, so what will be the electronic configuration? That will be K, L and M. Okay, so how many electrons will be present in that of the K shell? That is 2. How many electrons will be present in the L shell? That is 8. Now rest of the 6 electrons will enter into the M shell, so 6. Okay. Now you see here, student, last 6 electrons enter into the shell, and that shell is known as the valence shell. That is the outermost shell. So we will say that M is what? It is the valence shell. Now since this is the valence shell, so the electrons which is present in that of the valence shell will be equals to valence electron. So we will say that this is the valence electron. Right? So what will be the valence electron here, students? Valence electron will be equals to 6. So if valence electron is 6, what will be the valency? Now you see here, student, this is more than 4. So again we will apply the formula, that will be 8 minus number of valence electron. So what is the number of valence electron here, students? So that will be equals to 8 minus number of valence electron is 6. So 8 minus 6, and that will be equals to 2. Okay. So the valency of that of the sulfur is 2. Okay. So by this, students, I hope you have understood how to find the valency. At first you will find the valence electron. How will you find the valence electron? By the help of the electronic configuration. When you are able to do the electronic configuration, then you will find the valence electron. When you find the valence electron, you will see that whether it is less than 4 or more than 4. If it is more than 4, then you will subtract it by that of the 8. If it is less than 4, so you will simply write the number of valency is equals to number of valence electron. So this is the method by which you can find the valency of a given element. Okay. Now instead of that, if question is not given about that of the name of the atom, student, but simply it has been given that what will be the atomic number, what will be the valency of a given atomic number. Like if a question is like, if Z, what is Z? That is the atomic number. So Z is equals to 5. Okay, so if Z is equals to 5, what will be the valency of the element? Now you see here, student, here the name of the element is not mentioned, but the atomic number is mentioned. So you can see here, student, instead of that of a Z is equals to 5, it can be a Z is equals to 10, or Z is equals to 12, or Z is equals to 8, doesn't matter. Valency of the element. Okay, so you see here, student, if it is like Z is equals to 5, Z is equals to 7, you simply have to see that what is the atomic number, and with the help of the atomic number you can find the valency of the given element. Okay, so you see here, students, what is the valency here? Z is equals to 5. Right, now how will you find the valency? At first what we will do, we will try to find the electronic configuration of the given particular element. How many electrons will be there in that of the K shell, student? That is 2. And the rest of the 3 electrons will enter into that of the L shell. So it will be 2, 3. Okay, so you see here, student, this is the shell in which the last 3 electron enters. And you know that the accommodation, the power of accommodation of L shell is not 2, but it is 8. So it has to complete its octet. So we can say that this is the incomplete shell right now, because incomplete electrons are present here. Okay, so since it is the outermost shell in which the electron enter, we can say that this one is what? This is the valence shell. Here, in this shell, the number of electrons which enter into that of the valence shell is the valence electron. So here it will be valence electron. Okay, valence shell and valence electron, student. Now you see here, the valence electron is given as 3. So since it is less than that of the 4, so that will be equals to valency. So valency will also be equals to 3. Okay, so if it is less than 4, then valency will be equals to number of valence electron. If it is more than 4, then valency will be equals to 8 minus number of valence electron. Okay, so I hope you have understood the term valence electron. How can we find the valence electron, or how with the help of the valence electron we will find the valency. Now you see, the student, how this valency is useful. Remember when we were studying in that of the atoms and molecules to find the formula making. So there we have to learn the charges, what kind of a charges it will have, what kind of a charges this atom will have. So instead of that, if you knowing the atomic number of the particular element, especially from the 1 to 20, that is more than enough. So if you are knowing that, then it will be easy to find the number of valence electron, and as you are able to find the number of valence electron, you are able to find the valency, and by the help of that you are able to make the formula. Okay, let me give you one example. So before that, in the previous chapter when we were studying like that of a water, is a very easy example. So in the case of a water, how we used to find the formula of the water? So what we used to do, we used to say that since the charge on that of the hydrogen is +1, right? And in case of oxygen, the charge is -2. So we used to do like that. We used to see the charges. Whatever the charge will be present in that of the particular element will decide the formula. So here it will crisscross each other, and by this we can say it will be H2O. Since we will never mention the sign, and that is why it will be 2 and 1. Now you see here, students, that is okay. Okay, if you are knowing the hydrogen, we have learned about that of the oxygen, the charges, then it will be very easy to find it. Otherwise, if you are knowing the valency, so you see, in case of a water, in case of a water, student, this is hydrogen, this is oxygen. So you know that what is the atomic number of hydrogen? That is 1. Okay, so in K shell, 1 electron is there, and you know that it needs 1 more electron to complete its octet, so its valency will be 1. So what will be the valency here? 1. Instead of charge, we are writing valency here, remember that. In case of oxygen, what is the atomic number of oxygen? Atomic number of oxygen is 8. Right? So, what will be the electronic configuration of that of the oxygen? It will be 2, 6. Right? So, that will be K and N, 2 and 6. Okay? So, what will be the valence electron? 6 here. 6 is more than that of the valency. So, it will be equals to 8 minus number of valence electron. That will be equals to 8 minus 6 is equals to 2. So valency of that of oxygen is 2 students. So you will write here valency is 2. Now again you will use the same method, and by which you will crisscross each other and you will get the value, that is H2O. So instead Instead of learning the charges of the different atom, it will be very easy to find the valency with the help of valence electron. If you are knowing the atomic number of that of the particular atom, it will be very easy to find the valency of that particular atom. Okay, so with the help of the valency, student, you are able to make the formula that we have studied in the previous chapter. Okay. Now we will move to our next topic, students, and that is isotopes. That is isotopes. Isotopes, student. Iso, it means same. Isotopes means what? There are a different kind of atoms which is having the same atomic number, which are actually the same element, but their properties vary. When we were studying about that of a Dalton's atomic theory, student, there we had discussed the third postulate which was given by Dalton, that an atom which is made, an element which is made up of the same kind of atom will have the same properties. But what happened in the limitation? We find it that it is not necessary. There are some element which is having the same atomic number but different mass number, or there are some element which is having the same, which is made up of a same type of atom but their properties varies. The same thing, it is because of the isotope, student, that we discussed the limitation of that of the Dalton's atomic theory. So what is an isotope? Isotope, it tells that atom can have a same atomic number but its mass number varies. Okay, so we can define the isotopes are having same atomic number but different mass number. So you see, students, if two elements are there which is having the same atomic, if it is having the same, it means we are talking about the same element. So it can have a same atomic number but its mass number varies. Okay, so if its atomic number is same, what does that it indicate? It indicates, we know that what is atomic number? Atomic number of proton. That is equals to number of proton. Now atomic number is also equals to number of extra nuclear electron present around that of the shell. So number of proton is there and number of extra nuclear electron is there. Okay, so we can say the number of proton is equals to atomic number of electron is equals to atomic number. So if two elements, if X is there and Y, if two elements are there, that is X and X, both are having the same atomic number. If its atomic number is Z, here also it is Z. It means the number of proton present in both of them is equal as well as the number of electron is equal. So what is the thing which varies? Just because of that the mass number varies. So you know that mass number is equals to number of proton plus number of neutron. So you see here, student, number of proton never changes. So atomic number is same. That's why the number of proton will be same. So it is because of the change in the number of neutron, the number of a mass number will be different. Okay. So atomic number is same. It means number of proton is same. And if the mass number differ, then we can say it is because of the change in the number of neutron, the mass number varies. So we can write it. the mass number differ shows that the number of neutrons are different. Okay, because the number of proton and number of electron both are equals to atomic number, and that is why the atomic number is equals to this. So the number of proton and neutron will proton and electron will also be equal. So it is because of the number of neutron it varies. So mass number different shows that the number of neutrons are different from each other. Okay, so we can define isotopes, that isotopes are which is having the different number of neutrons. Okay, so we can write it. Isotopes are the atoms of the elements which differ from each other by the number of neutrons. Okay, so it is because of the number of neutrons, students, the isotope varies. You know that the atomic number is same, mass number differ, so it is because of the number of neutrons. Okay, so isotope, if anybody asks the definition of the isotope, you will say that isotopes are those elements which is having the same atomic number, but they differ from each other by their mass number. Now we can understand with the help of the example, so it will be very easy for us to understand. So first and foremost, to understand the isotope, the example we will take is hydrogen. So you see here, student, in case of a hydrogen atomic number is 1 and mass number is also equals to 1. Okay, so hydrogen, this is known as hydrogen, students. Now hydrogen exists in 3 isotopes. It is having 3 isotopes. It means it can exist in nature in 3 forms. What are the 3 forms? So the first form you have seen, I am writing it again. This is the first one, which we call as a hydrogen. Okay. The second one is hydrogen having the same atomic number, that is 1, but differ mass number, that is 2. Okay, so this one is known as deuterium. And the third one is in which hydrogen, again it is having the same atomic number, that is 1, but its mass number is 3. So here we use the term for it, and that is tritium. So one is the hydrogen, deuterium and tritium. Now you see here, student, all the 3 is having the same atomic number. Their mass number is 1, mass number is 2, mass number is 3. Okay, so here if you see the number of electron and proton, in case of a hydrogen it will be 1, and number of neutron will be equals to 0. Because the atomic number is 1, here the atomic number is, here the mass number is 1. So atomic number is equals to number of electron, that will be equals to number of proton, and number of proton is 1. So number of neutron, it will be 0. Here if you see, the number of proton is 1 again, and number of neutron 2 minus 1, that is equals to 1. So number of neutron will be 1 here. Okay, and here 3 minus 2, so number of atomic number of proton will be 1, and number of neutron it will be 2. So you see here student, these all vary just because of the number of neutron. Number of proton remains the same, and that is why the atomic number is same. But the number of neutron is